Welcome to our deep dive into deep learning and AI.
Yeah.
We're going to be looking at the deep learning revolution. It's by Terence J. Sijnowski, and he really dives into kind of the history and the key players, and he even makes some really cool connections to the way our brains learn.
Absolutely.
So it's a really interesting look at the whole field. Kind of where it came from, where it's going.
It really is. And what's so cool about it is it's not just algorithms, right? It's systems that learn,
Right.
systems that adapt, systems that, surprise us sometimes.
Yeah, absolutely. And it's like watching this intelligence emerge.
Yeah.
It's really kind of a mind-blowing thing. So I thought maybe we could start. There's this really interesting story about the DARPA Grand Challenge back in 2005.
Right?
And this was a race, but not just any race, right? This was a self-driving car
Yeah.
named Stanley.
Stanley.
And it won the grand prize,
$2 million.
$2 million.
Yeah. It was a big deal.
Yeah, and it navigated this 132-mile course.
Yeah.
It was through the Mojave Desert. And, I mean, you're talking like narrow tunnels and hairpin turns and even this crazy mountain pass called, get this, Beer Bottle Pass.
Beer bottle pass, that's right.
So this Stanley was equipped with this cutting-edge machine learning.
Oh, yeah. And that was really, I think, the point. Like, it was less about speed
Right.
and more about sort of the demonstration of what was possible with machine learning.
Right.
To take in all this complex data,
Yeah.
make decisions in real time in an environment that's totally unpredictable. Stuff like probabilistic robotics, computer vision.
Right.
These were huge breakthroughs for the whole idea of self-driving cars, right?
Yeah, and you think about how this is going to impact society. I mean, it's huge.
Oh, yeah.
I mean, you think about trucking and taxi industries, they're going to be totally disrupted.
Disrupted, yeah.
Urban landscapes, parking lots might be obsolete.
Nobody needs a parking lot anymore.
Right.
Yeah.
The way we think about car ownership even.
Oh, 100%.
It's amazing to think about. And then, it's not just self-driving cars, right? I mean, we're seeing this machine learning pop up in other places. Like, look at Google Translate.
Oh, yeah.
I mean, the accuracy, especially with speech recognition, it's mind-blowing.
It's amazing, and it does make you wonder if, keyboards are going to be
Yeah.
a thing of the past.
Right.
Yeah.
And then you think about the healthcare sector. I was reading at this company, Neurovigil, and they're using machine learning to analyze sleep patterns.
Right.
And the accuracy and speed is just incredible.
Yeah.
I mean, they can achieve in under a minute what traditionally would take, hours for a sleep expert to analyze. What do you think about that?
I think it's amazing, and I think that the potential is just huge, right? To get faster diagnoses, to be more accurate,
Yeah.
to personalize treatments, to understand things like sleep disorders in a much deeper way.
Yeah.
I mean, I think this is going to be huge.
Yeah. It really is. And we can't talk about deep learning without talking about one of the pioneers, Geoffrey Hinton.
Yeah.
And he was really, really big on this, brain-inspired approach to AI. And there's this great anecdote in the book where it says that, he used to call colleagues all the time and you'd be like, I've figured out how the brain works. So you just imagine this guy.
Yeah.
Super passionate.
Yeah.
Can you tell us a little bit more about his work and how it was different than maybe some of the prevailing AI approaches back then?
Yeah, I mean, he was definitely, doing something different
Right.
than what was, the sort of the standard AI approaches. Like in the 60s, the big thing was symbolic AI, which was like logic-based,
Right.
right? Like if this, then that. And at MIT, for example, there was this project called Blocks World where they were trying to, make a computer manipulate blocks according to these, pre-programmed rules.
Right.
And I think that really shows you the limitations of trying to, really program in all the complexity of the real world.
Right, because it's messy. Right.
It's messy, it's unpredictable. You can't just, make a rule for everything.
Right. It's like trying to fit a square peg in a round hole.
Exactly. And Sijnowski, the author of the book that we're talking about, he actually gave a lecture at MIT where he sort of challenged this whole paradigm.
Wow.
He was advocating for a brain-inspired approach using neural networks.
So he's going into, the lion's den, so to speak.
Yeah, exactly.
What kind of reaction did he get?
I mean, you can imagine.
Yeah.
Some faculty members were, let's just say, skeptical.
Right.
They were very entrenched in that symbolic AI approach. But there were others who were really intrigued by the potential of these neural networks.
So let's talk a little bit about those neural networks.
Okay.
Now, am I picturing this correctly? It's like this network, kind of like a web of interconnected processing units that learn from data. Is that kind of on the right track?
Yeah, yeah, you're thinking of like artificial neurons
Okay.
that receive, process, transmit information, and they're organized in layers.
Okay.
The connections between them, like the strength of those connections, those are called weights,
Okay.
and they determine how the information flows through the network.
So how do they actually learn, though?
By adjusting the weights.
Okay.
So it's kind of like how, your visual system, your brain learns to recognize objects by, detecting patterns and features.
Right.
Like you learn what an apple is
Right.
versus an orange
Right.
by seeing lots of examples of them, right?
Yeah.
And your brain is extracting those features that differentiate them.
So it's kind of like, training its eye,
Yeah,
so to speak.
exactly.
What were some of the early models like? I mean, how did they start out?
So one of the earliest was the perceptron,
Okay.
and it takes an input,
Right.
processes it based on these weights, tries to classify it, and the learning process is all about adjusting those weights based on feedback.
Right.
It's learning by trial and error.
So it learns from its mistakes.
Exactly.
Were there limitations with that model?
Yeah, so the perceptron, it was great for, simple problems, but it really struggled with anything that was more complex,
Okay.
like anything non-linear.
Right.
Like if you're trying to separate two groups of objects that have a really complex pattern, the perceptron can't do it.
Right. Like trying to draw a straight line
Yeah,
to divide up a curvy shape.
exactly. You need something more sophisticated.
Right.
And that's where the idea of multi-layered networks, which is really the basis of deep learning, comes in.
Okay.
So these have hidden layers of processing units between the input and output layers.
Okay.
So they can learn more complex patterns.
Okay, so this is where things get really interesting, right? So how do those multi-layered networks, how do they learn those complex patterns? It just seems like, I don't know, a whole other level of complexity there.
Well, that's where a key breakthrough came in. And that was this algorithm called backpropagation.
Okay.
And it uses feedback to adjust the connections between the units, not just in the output layer,
Right.
but throughout the whole network.
So it's not just like correcting the final answer. It's going back and tweaking the whole thought process.
Exactly. Yeah. It's like, if you're teaching a kid to write,
Right.
you don't just correct the final word.
Right.
You guide their hand as they're making each stroke, right?
Right.
And backpropagation is kind of like that. It's going back and adjusting all those connections
Wow.
to make it better and better with each try.
That's a great analogy.
Mhm.
So what kind of impact did this backpropagation have?
Oh, huge impact. Like one of the really cool successes was this network called NetTalk, and it learned to read aloud
Wow.
using backpropagation. And at first, all it could do was like make these weird sounds, like almost like baby babbling.
Oh, wow.
But with enough training, it actually learned to pronounce English words correctly.
Wow, so it was learning the rules
It was learning the rule
and the exceptions.
and the exceptions. Yeah.
That's amazing.
Yeah.
Any other notable examples of how backpropagation was applied?
Oh, tons. I mean, beyond language, people used it for things like predicting protein structures,
Wow.
detecting credit card fraud, all sorts of things. So it really showed how versatile this algorithm was.
So we've got these multi-layered networks. They're learning these complex patterns with the help of backpropagation.
Yep.
So what's the next step? Where do we go from there
Well,
in the evolution of deep learning?
yeah, I mean, things get even cooler
Okay.
from there. Well, one of the big things was convolutional neural networks. ConNets, they call them.
Continents.
Okay. And these were inspired by the visual cortex, so the part of our brain that processes, visual information.
Oh, so we're taking cues from our own brains.
Yeah, basically.
That's cool.
So ConNets, they use filters to extract features from images, kind of like how our brains do it.
Yeah, okay.
So they're looking for edges and shapes and textures and, all those patterns that help us recognize what we're seeing.
Like little digital detectives.
Yeah, exactly.
Going through all the visual clues, what kind of impact have they had?
Oh, huge. I mean, they revolutionized computer vision, like object recognition, for example. They've gotten so good that in some cases, they actually outperform humans.
Wow, that's kind of scary, isn't it?
It is a little bit, yeah. But it shows you the potential of deep learning to really change how we do things in all kinds of fields.
Absolutely.
Oh.
So we've got these ConNets, and they're doing all this amazing stuff with visual data.
Right.
So where do we go from there? What's next in the AI world?
Well, another really cool area is reinforcement learning. And this is where AI agents, they learn by trial and error. And they get rewards for doing things right. So it's like, imagine you're training a dog.
Okay.
You give it a treat when it does something good, and
Right.
it learns to repeat that behavior. So it's not about programming and rules, it's about letting them figure it out.
Learning from the consequences.
Exactly. Yeah. And one of the key algorithms here is called temporal difference learning, TD learning for short.
TD learning, okay.
And this allows the agents to predict future rewards. So based on what they're doing right now, they can kind of think ahead and be like, okay, if I do this, what's going to happen?
That's pretty smart. Any real world examples of this in action?
Oh, yeah, for sure. One of the early successes was TD Gammon. It was a program that played backgammon,
Okay.
and it got really, really good, like expert level.
Wow.
And it learned by playing millions of games against itself.
Wow.
So just, refining its strategy over and over and over.
That's wild. So like DeepMind's AlphaGo that beat the world champion at Go, is that using a similar approach?
Yeah, AlphaGo uses a combination of deep learning and reinforcement learning, builds on the same principles of TD learning.
That's incredible. And what's really interesting is that there's actually a biological basis for this whole reinforcement learning thing.
Yeah.
Scientists have found that these dopamine neurons in our brains, they actually signal reward prediction errors.
Yeah.
So it's like our brains are kind of wired for this type of learning.
Yeah, it's amazing, isn't it, that there's this connection between, what we're building in AI
Right.
and how our own brains work.
It's this whole deep dive has been fascinating, and we've talked about everything from self-driving cars to sleep analysis, language translation to game-playing AI. I mean, deep learning really seems to be touching every aspect of our lives.
It really is.
What stands out to you as the most significant aspect of this field?
I think the most exciting thing is the speed at which it's all happening. And the potential applications, I mean, it just seems limitless. And one area I'm particularly excited about is social robots that are designed to interact with, like, young children.
Oh, yeah. I remember reading about those. What's so special about them?
Well, what's cool is that they're learning to actually interact with kids in a natural way, not just, following a script. It's a huge difference from those old clunky robots we used to see.
Yeah, it's like the difference between talking to a chatbot and having a conversation with a real person.
Exactly.
So what's driving that shift in robotic interaction?
Well, there's this idea of embodied intelligence.
Okay.
So these robots, they're not just processing information in a vacuum.
Right.
They're learning by actually interacting with the world, right? They're sensing their environment, they're making decisions, they're adapting based on feedback.
So it's not just about thinking, it's about doing,
Yeah,
experiencing.
exactly. And I think this has big implications for how we think about intelligence in general.
Right.
It's not just about computation, right? It's about, embodiment. It's about lived experience.
Yeah.
We're starting to see a more holistic view of intelligence, I think.
It's like we're getting a glimpse into this, this dance between nature and technology,
Yeah.
between our own brains and the machines that we're creating.
It's pretty amazing.
It is. It's really cool. This reminds me of our earlier conversation about, the early days of neural networks and how there was kind of this skepticism, right?
Ah.
This resistance to this new approach.
Yeah, and there was actually a period in AI research back in the 60s and 70s that's often called the AI winter.
The AI winter.
Yeah, it was like this time when funding dried up, research slowed down, the whole field basically went into hibernation.
Wow. It's hard to imagine that now, given all the excitement around AI.
I know, right?
So what caused this deep freeze? What happened?
Well, a few things, I think. One was that those early neural network models, like the perceptron,
Right.
they had limitations, right? They couldn't solve a lot of real-world problems, so people got disillusioned.
Okay.
And also, symbolic AI, the logic-based approach, that was still really dominant.
Right.
And while it had some successes, it also had trouble handling the complexity of real-world data.
Right, because you can't just, write a simple equation to capture something like human emotion.
Exactly, yeah. And so there was this battle, between symbolic AI and neural networks.
Right.
And symbolic AI was seen as the more promising path at the time, so that's where the money went.
So neural networks kind of got left behind.
Yeah, for a while.
So what brought them back? How did deep learning emerge from this AI winter?
Well, a few things came together. One was that computers just kept getting more powerful.
Right, because we talked about how these deep learning models need tons of data.
Tons of data, yeah, and lots of processing power. So as computers got better, it became possible to run much larger and more complex simulations. And then there were new algorithms like backpropagation that, helped train those multi-layered networks. So it was this perfect storm of technology and, theoretical breakthroughs that really revived the field.
But I'm sure there were people who kept the faith during those lean years, right? Who kept working on this stuff.
Oh, absolutely. Researchers like Geoffrey Hinton, Jan LeCun, Yoshua Bengio, they never gave up. They kept refining algorithms. They kept exploring new architectures. They laid the groundwork for everything that came after.
So they were the unsung heroes,
Yeah, pretty much.
the ones who kept the flame alive.
Yeah.
And their work eventually paid off.
It did. In the early 2010s, deep learning started beating traditional methods in, things like computer vision and speech recognition.
Okay.
And people started to take notice. It was undeniable. It's a great example of how, persistence and dedication can really pay off.
It's an inspiring story. So, speaking of pushing boundaries, what about the impact of deep learning on, like, finance? That seems like an area that's ripe for disruption.
Oh, yeah. Finance has been all over this stuff, especially hedge funds.
Right.
I mean, they're using deep learning to analyze market data, to predict stock prices, to make investment decisions, and it's all happening at lightning speed.
It's like having a superpowered financial analyst.
Pretty much, yeah.
So what are some of the key applications there?
Well, they're using it to assess credit risk, to detect fraud, even to personalize financial advice. I mean, the potential is huge.
Right.
But, there are also some big questions about, how to use this technology responsibly.
Right.
What are the potential consequences?
It's a lot of power.
It is, yeah. So we have to be careful.
Absolutely. This brings us to, kind of a fundamental question, and that is, what are the limits of deep learning? Can these systems actually achieve human-level intelligence, or are there just some fundamental differences between artificial intelligence and, our own brains?
Yeah, that's the big question, isn't it?
Yeah.
And deep learning is really pushing us to confront it.
Yeah.
I mean, some people think that with enough data and enough computing power, we can create AI that surpasses human intelligence in every way.
Okay.
Others think that there's something special about human consciousness, about creativity and intuition that, machines will never be able to replicate. It's a philosophical question,
Right.
and there's no easy answer.
It's interesting to think about, like, maybe intelligence isn't just one thing. Maybe it's a spectrum of abilities, and each one has its own strengths and weaknesses.
Yeah, that's a good point.
Maybe you're just seeing the emergence of new forms of intelligence.
Right, that challenge our traditional ideas of what intelligence is.
Exactly.
Like, look at the animal kingdom, right?
Right.
You've got chimps that are great at problem solving, dolphins that are amazing at communicating, bees that can navigate incredible distances. Each one has its own unique cognitive toolkit.
Yeah.
So maybe AI is just, expanding that spectrum,
Right.
adding new forms of intelligence that, complement and challenge our own.
And it's humbling, isn't it?
Yeah, it is. To think that we might not be the only intelligent beings out there,
Right.
or even the most intelligent.
Yeah. It's pretty mind-blowing. And what does that mean for our future?
I mean, that's the big question, right?
Yeah.
As AI systems get more sophisticated, they're going to play a bigger and bigger role in our lives.
Right.
They're going to shape our decisions. They're going to influence our perceptions, maybe even challenge our values.
Yeah.
It's a future full of both, incredible opportunities and potential dangers.
It's exciting and scary at the same time.
It is. And I think it's important to remember that we're not just passive observers in all of this.
Right.
We're active participants. We're shaping the future with every decision we make,
Yeah.
every path we choose to explore.
This is really what this deep dive has been all about, isn't it?
It is. I mean, it's not just about algorithms and data. It's about us. It's about our understanding of intelligence, our relationship with technology, our responsibility for the future.
Yeah. And it makes you think back to that question of whether deep learning systems can reach human-level intelligence.
Right. It's not just science fiction anymore. It feels like we're really wrestling with that question now.
Definitely. And it forces us to rethink what intelligence really is. For a long time, AI research was all about trying to copy how humans think, the logic to problem solving.
Right.
But deep learning is showing us that there might be other ways to get there. It's not always about mimicking our own brains.
It's like we've discovered some alien intelligence that works in ways we don't fully understand yet.
That's a good way to put it. So if these systems can do things better than us, in some areas at least,
Right.
does that mean they're intelligent? Or are they just tools? Very sophisticated tools, but still just tools.
It's like that argument about chess players versus chess computers.
Yeah.
The human uses strategy, intuition, experience, but the computer just calculates and recognizes patterns. And yet, they can both win,
Right.
just in different ways. Maybe intelligence isn't just one thing. Maybe it's a whole bunch of different abilities, all with their own strengths and weaknesses.
Like in nature.
Exactly.
You've got chimps that are great problem solvers, dolphins that are amazing communicators, even bees. They navigate over these incredible distances. They all have their own kind of intelligence.
Yeah, and maybe AI is just adding to that, bringing new forms of intelligence into the mix, forms that we can learn from and that can challenge us.
It's pretty humbling to think that we might not be the only intelligent beings around.
Or even the smartest.
Right. So what does all of this mean for the future?
Well, as AI keeps getting more powerful, it's going to have a bigger impact on our lives.
Right.
It'll shape how we make decisions, how we see the world, maybe even our values.
It's exciting, but also a little scary.
Definitely. And I think the important thing to remember is that we're not just watching this happen, we're part of it. We're shaping this future with every choice we make.
That's what this deep dive has been all about, right?
Exactly. It's not just about the technology, it's about us. How we understand intelligence, how we interact with machines, and what kind of future we want to create.
It's been an amazing journey, exploring the history of deep learning and AI, thinking about where it's all going.
Yeah, it's a fascinating field.
And it's clear that we're living in a time of huge change.
For sure. A time of incredible opportunity, but also some big challenges.
So as we move forward, I think it's important to stay curious,
Absolutely.
to keep learning
Yeah.
and asking questions.
The deep learning revolution is just getting started.
Thanks for joining us on this deep dive. We hope you learned something new and that you're as excited about the future of AI as we are.
Thanks for listening.